Okay. All right. So here we go. This is the stepladder problem. All right. So 4-meter long bar. So let's draw this guy. Here's our bar. Problem tells us that it is 4 meters long, and it tells us that it weighs 400 newtons, and the center of gravity is 1.5 meters from one end. Everybody cool with that? Okay, and it was arbitrary that I put the center of gravity on the left. I could have just as easily put it on the right. Cool? All right. A weight of 300 newtons is attached at the heavy end. So I was trying to talk about this yesterday. I wish I'd done it at the start of the hour. Does everybody understand that this end over here has to be the heavy end? Right? Because like if this was a baseball bat, then this would be the fat end, right? Okay, because that's why the center of mass is over there. Okay, so a 300 Newton weight is placed over here. Let's call that F1, 300 newtons. Okay, and then it tells you a 500 Newton weight is hung from the other end. Okay, so there's your drawing. Is everybody okay with that? We're good? Okay, so you place a ladder under the bar to balance it. So somewhere, this is very similar to what we did yesterday, somewhere we're going to take a step ladder and we're going to put the step ladder under it somewhere to get it to make the bar balance. Cool? All right, so this problem is different from most of the other problems on the worksheet because instead of having 2 unknown forces, we've only got 1 unknown force and an unknown distance. Okay, I feel like a broken record. My recommendation is find the missing force. So first of all, name the missing force. What missing force is there? The ladder, right? We don't know how much force the ladder's exerting. So whatever, I'm just going to pick a random spot. Let's say the ladder goes there, okay? So here we go, force of ladder. All right, so whenever you've only got 1 missing force, you can find it by saying, well, your net force has to be 0, right? So that means that all 4 of these forces have to add up to 0, right? So net force is force 1 plus force of gravity plus force 2 plus the force of the ladder. Net force has got to be 0 because the beam isn't moving, so you get 0 is negative 300 minus 400 minus 500 plus the force of the ladder. Force of the ladder, 1,200 newtons. You good up to there?
Yeah.
Everybody good? Alrighty, so now we got to figure out where the ladder goes. All right? Pick your pivot point at the end. All right? The fulcrum does not have to be the pivot point. All right? Like I'm looking at this and I'm thinking, oh, well, the board can kind of wobble like this on that ladder, right? And so your natural inclination is to think, oh, if it pivots, it's going to pivot on the ladder. Okay? But the whole point is, if it's balanced, it doesn't pivot anywhere. So you can pick any pivot point you want. All right? So here we want to pick our pivot point at the end. Do you guys understand? If I was to choose the pivot point here, the problem is I end up with 3 unknown distances, right? Because I don't know the distance to any of my forces because I don't know where the ladder is, right? So that's a bad choice, all right? So pick your pivot point at one end. Noah, pick an end.
The lighter.
This guy?
Yeah.
All right, so label it. P, pivot point. All right, and then our net torque has got to be 0. So let's see, our net torque is the torque from force 1 plus the torque from gravity plus the torque from force 2 plus the torque from the ladder. Yes? Cool. All right, and I think this is a good idea. Like, take a second and write them out with letters first. All right, so let's see. Our net torque has got to be 0 because everything is balanced. Torque from force 1, that's 300 times 4, right? Everybody good with that? All right, and that's going to make it spin counterclockwise, so that one's positive, right? All right, and then we've got the torque from gravity is 400 newtons times this distance, right? So if this is 1.5, this must be 2.5. Follow? Plus the torque from force 2, which is What's the torque from force 2 going to be, guys?
0.
0. And then plus the torque from the ladder. So the torque from the ladder is 1,200 newtons times D. And then solve for D. Okay? I'm going to not put the -1 in. So if you solve this, what ends up happening is you end up getting 1,200 newtons times D equals negative 2,200, I guess. Good. So what this is telling me then, this is telling me that the torque produced by the ladder has got to be negative. So, I mean, it's obvious in this problem, but let's see, I know the ladder is pushing up, and my pivot point is here. So it's telling you that since your torque has got to be negative, your pivot, it's got to be to the left of the pivot point, right? Because if it was to the right of the pivot point, you have clockwise torque.
Don't you know that already since? Okay.
Yeah. But some, you know what? I've written problems before where I haven't like figured them out in advance, but it's been such that like I haven't worked the numbers out in advance, and you solve it, and it turns out that the ladder has to be like over here. You know what I mean? Or just in a complicated scenario. So it is possible that I'm doing a crap job explaining this. Anyway, the point is your torque has to be clockwise, which means the ladder has to be to the left of your pivot point. Is what I'm doing a rotten job saying. Good, you guys? All right. So.